Hi everybody, this is Mrs. Ellsworth. And what we're going to be talking about today is using our periodic table to figure out how many protons, electrons, and neutrons that there are in atoms. Okay, and so we're going to first of all start looking at the carbon atom. Okay, and my apologies, I got my computer cleaned off and I do not have a notebook on one and I do not have a microphone with the other, so I had to go and pre-record this with no sound, and now I'm adding sound to it, so hopefully it'll all match up just fine. Anyway, so when you look at your periodic table, and you need to write out these notes. When you look at your periodic table, there's a blue 6 on carbon, and then there's a 12.0107 on it. And so let's explain what all these numbers mean. The blue number is the atomic number, and the atomic number is special. This is what we identify each element on the periodic table with. Now each one has their own mass, and that's the atomic mass right there in the red. Okay, and the atomic mass can also be called the atomic weight. Okay, and then what are the last two things on that square there? We've got the symbol for the element, and we've got also the element name. Okay. So with this information, we can find out how many protons, electrons, and neutrons are in an atom, in the carbon atom. So here's what we use it for. We use the 6 and the 12.0107 to calculate the number of protons, the number of electrons, and the number of neutrons. Now the protons are there are 3 particles inside the atom, okay? And the protons are the ones that are positive, and the electrons are the ones that are negative. Remember Thomson, he discovered the negative electrons, and anyway, he knew that there was also positive mass in there. Then Rutherford, he figured out that, hey, that there's both of these inside the nucleus. He discovered the protons. Excuse me, there's both of these two inside the nucleus, and then there's the electrons hanging around outside there. Then Bohr realized later on that actually that these electrons are actually in those energy levels, and we're going to talk about those because it really explains a lot about how that the atoms are connecting to other ones and that they're bonding. But neutrons, let me show, I'll just mark those as an equal sign. They have no charge on them. And anyway, so we're going to calculate the number of protons, electrons, and neutrons that are inside the carbon atom. So when we look up at the atomic number, that tells us something so important. That tells us the number of protons. Actually, it also tells us the number of neutrons, but, I mean, we'll get, that's in this one here. Let me repeat myself later on. That's the number of protons and sometimes the number of electrons. Now, the atomic mass. The mass tells us simply that we add up the number of neutrons and the number of protons, and we get the number 12. Okay? So we can subtract those two numbers to find the number of neutrons in any atom. Okay? But we change it to the mass number, we round it because we want a perfect number there, and I'll explain how we do that. I'm going to go through this one kind of quickly, and then we'll go through another one. Again, the atomic number is 6, so there's 6 protons and there's 6 electrons. Because this is a neutral atom, all atoms are neutral, there are going to be the same number of protons as there is the same number of electrons. Then we subtract the 12 and the 6 that you get from the mass number and the atomic number, and then we will get the number of electrons, which will be 6 electrons. Now, I picked a bad number on here to go and do an example, but oh well. Anyway, so there's 6 protons, 6 electrons, and 6 neutrons. So we can, with this information, we can figure out what does this atom look like. If you remember right, Bohr knows that it's got a small, dense nucleus. Okay, and then it's got energy levels on the outside. I don't know why I crossed that out, but oh well. Anyway, so for carbon, we also write a symbol as a 6 or 12. It could be also twisted around there backwards, but that's how we usually generally write them. And so let's figure out, we've got a nucleus. Let me color this here. In our nucleus, we've got, oops. Oh my goodness. I see I have an error. This is supposed to be a neutron here. Oh my goodness. That's neutrons right there. So make sure you get that right in your notes. And then the first energy level surrounding it, it has got 2 electrons and 4 electrons. Let me explain how we get this. The very first energy level can only hold a maximum number of 2, and the second one can only hold a maximum number of of 8 electrons. And I'll explain how we get that here in just a second with another one. I just want to do a preview of what the atom looks like for the Bohr model. It's got protons and neutrons in the middle there. And it's got electrons in their certain energy levels here. And I'll explain how we get those numbers here in just a minute. Let's look at aluminum next. Okay, aluminum, when I look it up on the periodic table, is number 13. And it's got also a 26.98 blah, 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 blah. And so I'm going to go and reduce, just go and change that into a whole number. We're going to go and round it up to 27. And so from this information, we can find the number of protons, electrons, and neutrons. Okay, so there's 13 protons. Same number of electrons again, because we want the same number of both so that we have an equal, neutral atom. Okay, so there's the same number of each. Otherwise, it's not neutral. Okay, and then the number of neutrons, we're going to subtract 27 minus 13. And we'll get 14 neutrons. Okay, let's make sure that I got this one right. Inside the nucleus, we have got 13 protons and 14 neutrons. Okay, and I colored it so you can see that this is the nucleus. It's supposed to be teeny tiny small, but we won't be able to fit everything in there. Okay, electrons are surrounding it. Okay, now the first one can, I'm not going to write out the whole circle. Anyways, the first one can only hold a maximum of 2 electrons, and I'll show you with your periodic table how we get these numbers here. The second energy level can only hold a maximum of 8 only. And after 10 electrons, which we've got 13 electrons, after that we just keep on going till we fill it up to 13 electrons. Okay? Now, how did I get those numbers? Well, let me show you with the periodic table here. The first level on the periodic table represents the energy level, the number 1 energy level. It can only hold 2. Notice that there's only 2 atoms up here. They represent the electrons. Over here there's now 8 electrons. Okay, and then there's 8. This whole periodic table represents the Bohr model. It's just amazing. And so right across here, if you count straight across, there's 18 of them. 18 on the next one. And then these 2 rows right here, we have to add these 14. Remember, the periodic table is really long and skinny. I've got a poster of it right in the front of the classroom. And there are 32 in this row and 32 in that row. So, this fits inside of there. And a reminder, what does that mean? There's 2 in the first energy shell that goes around, or that energy level that goes around the nucleus. 8 in the second, 8 in the third, 18 in the fourth, 18 in the fifth, and 32 in the sixth, and 32 also in the 7th energy level, surrounding that nucleus. So let me try and move this up here, and we'll do an atom that, so you can see the periodic table at the same exact time. Oh, let me go back and remind you that that's the numbers 2, 8, 8, 18, 18, 32, 32, and that's how I got those numbers for aluminum. Okay, so let's look at a different element here. Let's look at iron. Okay, iron is number 26 on the periodic table, and it has got an atomic mass of 55.95, blah, 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 blah. So we'll just go and round it to give the mass number. And so with this information, we can figure out the number of protons, which is 26 protons, 26 electrons, because again, they have to be the same exact number. And the neutrons is going to be 56 minus 26 for 30. Okay, so in that center, we'll put the protons and the neutrons, and then we'll worry about those electrons and those certain patterns going around it. Oh, that's too dark. There we go. Okay, 26 protons and 30 neutrons. Now we've got to worry about those electrons going around it. For some reason, students will quite typically put in 30 electrons. No, that's 30 neutrons over there. We need 26 electrons. Okay, so we got, it goes 2, 8, that's 10. We need 26, so we need another 8. Okay, that's 18, so we need just 8 more. Yeah, 18 plus 8 is 26. Okay, so just 8 more electrons there. Okay, so that adds up to 26. I want to also show you how we double check this. Okay, look at this. There are 4 energy levels here. 1, 2, 3, 4. If you look at the periodic table, here's the first energy level, second, third, fourth energy level, or fourth row. Okay, how many electrons do I have down here? I have 8 in the outermost shell. 1, 2, 3, 4, 5, 6, 7, 8. So you can always double check your work. Sometimes I will see students go and write out 2, 8, 8, and then they'll count over 8 here and go backwards. And then they'll write them out, and then they'll go add them up and make sure that they add up to 26. And that is an excellent way to double check your work, because so often students will go put the number of neutrons for electrons. Again, why do you think that we label these things? Again, you must label them to get any credit. Anyway, we label them for a reason, and that's so that you get things right. Okay, let's go ahead and look at a different element now. I'll try and keep some of this up here. Maybe I should make this smaller. Okay, I'd like you to look at iodine. It is located here on the far right. Okay, and I'd like you to write out a symbol and the 2 numbers that it represents. Their 2 numbers are going to be 53 and 126 point blah blah blah. We'll round it to 127 because it's 0.5 or higher. And so now we know that we can fill up the number of protons, electrons, and neutrons. The number of protons are 53. It's the smallest number always. And the electrons is always identical. And then we have to go and subtract some numbers to find the number of neutrons. Okay, because that makes sense. The bigger number contains protons and neutrons, and the smaller number is just protons. So there's my nucleus. And pause it here and go ahead and write out the number of electrons. Okay, we've got 2, 8, 8, 18. Okay, and that is 36. And we'll go and subtract that. We got 17 left over. Okay, and don't forget to double check. You've got 2, 8. How many rows have we got here? 1, 2, 3, 4, 5. The 5th row over, I counted and I saw 17 of them, so that would be perfect. Okay, sodium. One last one here. Maybe we'll have time for more. We'll see. Okay, so sodium. Okay, we're doing just a small one for practice here. And so sodium has got 11 protons. 11, oh, wait, why don't you go and pause right now and quiz yourself on this. Pause it and show what that whole atom looks like. Remember, I got 11 protons, 11 electrons, and then 12. So pause it and then see what it looks like here in just a second. Okay, hopefully you quiz yourself and you realize that the 11 electrons, it goes 2, 8, and then 1. And you can go and count that. The 3rd energy level down is just one of them. Here, let me show you what I mean. There's 3 rows because there are 3 energy levels here. So you go down 3 rows, and then you go over 1. Okay, let me show you what I mean. Okay, go down 3 rows and you go over 1, and that is sodium. So you can always go and double check it. Go over 1, 1 sodium. Okay, so that is how you do these. If you'd like to, there are 2 examples at the top of your worksheet. Chlorine and gold. I've got the examples for your teacher to show you how to do them. So quiz yourself. Also, there's that section right in the middle of it, and that would be, there's that little rectangular box up at the top of your pink sheet that's got those 7 energy levels. What do those numbers represent? Well, it's these ones right here. It's these, the 2, 8, 8, 18, 18, 32, 32. So you've got the rest of the period now to work on your Bohr models. So that's only about 30 minutes. So you've got to figure out your PEN for each one. Then you go and you draw your Bohr model with, don't forget to label your protons and your neutrons inside the nucleus of that atom. Then you've got your energy levels, and the maximum number